This is R.D. Sharma solution class 12 chapter 5 Algebra of Matrices. Exercise is 5.3. So A is given a cube minus 4a square plus a equals 0 or null matrix. Second one is A is this matrix and we have to find out a to the power 4. So the first part I am telling you, this is a cube minus 4a square plus a. Either you do a square and a into a cube, or what you can do is you can just take a common. That is a dot a you can do. So the best way to solve it, if this question is of 2 marks or 3 marks, just take a common. The inside will be a square minus 4a plus I. So you just have to find out a square. Now you don't have to go for a to the power 3. So when you compute this, it will come as 0. So this kind of question we have already done. So let us take the second part. So you have to find out a square minus 5a plus 7i equals 0. Use this to find a to the power 4. Okay. So this you have to prove that it is equal to 0, and using this we will compute a to the power 4 also. Okay. So let us see how we do it. We have to use this a square minus 5a plus 7i, that is a square equals 5a minus 7i, to find out a to the power 4. So let us see a square. This a square, since a is already given, in order to find a square, so this is 3, -1, 1 and 2. This is also 3, -1, 1, 2. So row column, 3 is a 9 and 1 minus 1 is -1. 3 ones are 3 and 2 ones are 2. -3 and -2, -1 and 2 is a 4. Okay. So what do you get? 9 minus 1 is 8. This is 5. This is -5. And 4 minus 1 is 3. So this is your a square. Okay. Now we have to put in here in this equation. It will come as 0. So let us put it in the equation. This matrix minus 5 into a. So I am directly multiplying this matrix with 5 and putting it here. So 5 is a 15, 5, -5, and 5 is a 10. What about 7i? Identity matrix is what? 1, 0, 0, 1. The diagonal is 1 and multiplied by 7. So only the values which are 1 will become 7. Now let us do it directly. 8 minus 15 plus 7. 5 minus 5 plus 0. Then we have -5 minus is 5. And then plus 0, 3 minus 10 plus 7. So 8 plus 7 is 15. 15 minus 15 is 0. So you get a 0. 5 minus 5, 0. 5 minus 5, 0. 3 plus 7 is 10. 10 minus 10, 0. So what do you get? This we have already proved now. So now we'll find out a to the power 4. So a square is already with us. This equation, from this equation, a square I am taking 5a and 7i on the right hand side. So a square will be 5a minus 7i. Right? So let us do a cube, that is multiply this with a matrix dot a. So a cube will be 5a square minus 7 into a into I is already a. Don't write I, because a into I, anything multiplied with identity matrix will be the same matrix. This is a cube. So on the right hand side, a square is there, and a square we already know. What is a square? A square we already know. A square is 5a minus 7i. So a square is 5a minus 7i. So we will replace this a square with 5a minus 7i. Right? 5a minus 7i minus 7 into a. So this will be 25a minus 7 5 is a 35i minus 7a. So 25 minus 7a, what it will be? So this will be 18a minus 35i. So this is the first step for a to the power 4. A cube we have already got. Now we have to find out a to the power 4. So a cube will be multiplied by a again. So I am multiplying the right hand side also by a. I am doing it here. A to the power 4 will be 18a into a, that is 18a square minus 35a into I will be a. So 18a square is what? 5a minus 7i. It will be 5a minus 7i. 18 into 5a minus 7i minus 35a. So this is 18 into 5, that is going to be 90, and 18 into 7 is 126 minus 35a. So when we do 90a minus 35a, what it will be? It will be 55a. 55a minus 126i. This is your a to the power 4, but still things are not over, because you have to replace. A is already given, no? 55 into a is what? 3, 1, negative 1, 2. And minus 126 into I. What is I? 1001. Multiply this by 126 and put in here. It will be 126, 0, 0, 126. Now multiply these two. 55 into 3 is what? 165. 55 is there, minus 55 here. 55 into 2 is 110. Now subtract these two. 126, 0, 0, 126. 165 minus 126 will be 39. First one will be 39. 55 minus 0 is 55. Minus 55, 0 is minus 55. 110 minus 126 is going to be minus 60. So what was that? This is a to the power 4. This is the final value. This is an important question I am telling you, NCERT. So here we have to, we have already done a question like this, the k's or the lambdas. Okay. So let us do it. A square equals ka minus 2i2. A square is 3, 4 minus 2 minus 2. So I am not doing a squared because I am taking directly from here. I am pretty sure that you will be able to do it. A dot a you have to find out. And the final is I am writing this is a square equals k into a. So multiply everything by k. So it will be 3k, 4k, minus 2k, minus 2k. So I am just multiplying a scalar multiplication of this with this matrix. 3k, 4k, minus 2k and minus 2k. Minus twice into I2. I2 is 2 by 2 identity matrix. So 1001. So just write 2 inside because 2 is a scalar multiple. Now I am taking the right hand side value on the left hand side. This is 1 minus 2, 4 minus 4 already. So I am adding it with 2, 0, 0, 2. And on the right hand side it is going to be 3k. I'll write all the value, but we don't need all of these. We need just one of them. So now just take this 2 plus 1. I'm just taking one of them. 2 plus 1 is 3k. This one. You have to do all of these, okay? I'm just telling you k will be equal to 1. Same thing here. CBSE 2005. So I hope you'll be able to do. Just multiply a twice. A square will be there. Multiplied by a 8 and then multiplied by k identity 1001. So k will be equal to 7. So I am just doing it quickly because this exercise has a lot of questions. The multiple of them are equivalent, similar. Coming to this a, this is a kind of same question, but here is a twist, because what is the twist? Only the expression which is given. CBSE 2005. This is fx is given as x square minus 2x minus 3. And we need to find out fa. Fx is this. Fa will be, just replace wherever you find x, just replace it by a. It will be a squared minus 2a minus 3. So just a dot a. So I am not doing it. I am just telling you what is the value. A square I am using directly. I hope you will be able to do it. It will be 5, 4, 4, 5. And minus twice of this. So multiply this with 2. So multiply this by 2. So 2, 4, 4, 2. Okay. Then minus 3. 3 into I it has to be. It will always be identity matrix. So it will be 3, 3 on the diagonal. So 3, 0, 0, 3. Now let us compute. 5. Let me show you here. Take a different color. 5 minus 2 minus 3. And that is actually 0. 4 minus 4 minus 0. That is also 0. 4 minus 4 minus 0. That is also 0. And 5 minus 2 minus 3. That is also 0. This is FA equals 0. And that is what needs to be found out. So we have showed it. FA equals 0 here. Now this is A equals this, I is this. Find lambda and mu so that A square equals lambda A plus mu I. This A cube minus 4A square plus A equals 0. Okay. So the first one I am doing, A square plus lambda is equal to lambda A plus mu I. So A square, I hope you'll be able to do A dot A, just multiply this metric with the same metric. And A dot A I am directly writing. This is going to be 7, 12, 4, 7. Remember, this is A square. I have not done it. I have just taken it from here. A square. So this is A square. This is equal to lambda into A. So take A multiplied by lambda. Lambda is the scalar multiple. So now it will be all 2 lambda, 3 lambda, 1 lambda means lambda and 2 lambda. Now add it with mu I. Multiply this with mu. It will be mu 0, 0, mu. Okay. So let us add 2 lambda plus mu. 3 lambda plus 0 is 3 lambda. Lambda plus 0 is lambda. 2 lambda plus mu is 2 lambda plus mu. So on the left hand side you have 7, 12, 4 and 7. On right hand side you have this one. So lambda you don't have to worry because lambda is directly being seen. This is already equal to 4. Lambda is already 4. Okay. Now put in any of the equation. You can take any of the equation. Let us take this one. 2 lambda plus mu equals 7. This is 7. Lambda is already 4. So 2 into 4, that is 8 plus mu is 7. Mu is 7 minus 8, that is negative 1. Okay. Now the second part, as I already told you, you can do it if this question is of 5 marks. But if it is of just 2 marks or 3 marks, you can just take A common. A square minus 4A plus I equals 0, and definitely this is going to be 0. Find the value of X for which the matrix product is an identity matrix. So we'll do the matrix multiplication and we'll equate it with the identity matrix. So I'll do it directly here one by one. This row, first row with 3 columns, second row with 3 columns, third row with 3 columns. So first row, 2 into minus x is minus 2x, 0 into 0, leave it. 7 into x, write it, 7x. 2 into 14x, now this 207 will be with the second column. 28x, then 0 into 1, 0, 7 into minus 4x, 7 4 28, minus 28x. The first row with third column, 2 into 7 is 14x, 0 into 0 is 0, 7 into 2, that is minus 14x. Now second row with first column. Now see how to reduce the calculation. First and third is already 0, and this row will always be multiplied with the middle one, will always be multiplied with the middle one. So just take the middle row of the second matrix and put in here. I hope you got the idea. When I take 0 1 0 1 0 multiplication with every one of these on the right hand side, means the column wise, 0 1 0 will remain. Now 1 into minus x, third row with the first column, minus x, and 0 will be 0 and plus x. Then third row with second column, 14x minus 2 and minus 4x. Then last row with the last column, 7 to 7x minus 2 into minus 2, leave it. 1 into minus 2x is minus 2x. Okay. So this is equal to identity matrix. I'll just write the identity matrix. This space is less. So we'll compute the left hand side and just equate it with the right hand side. That is the identity matrix. Let me compute it here. So this 7x minus 2x is going to be 5x. Let me change the color. 7x minus 2x is 5x. This is going to be 0. 14x minus 14x is 0. 0, 1, 0. This is also 0. 14 minus the last one is 5x. 14 minus 6x. That is going to be 14 plus minus 4 is 10x. 10x minus 2. That is going to be 10x minus 2. Now this is equivalent to this is equal to the identity matrix. Identity matrix, because we have to write 3 by 3 matrix, and the column values all will be 1. 1 0 0 0 1 0 0 0 1. Okay, 5x is equal to 1. Just equate it. X will be equal to 1 by 5. So all this you have to put a lot of effort, but in the last you see just 1 will be equated and x will be 1 by 5. 10x minus 2 is also 0, so 10x will be 2, x will be equal to 2 by 10, that is going to be 1 by 5. Solve the matrix equation. This is NCERT. So these all type we have already done. You just have to multiply and equate it to the null matrix, that is 0, and that x will come. This is NCERT and very important. But this type of question we have already done. So we'll try to take a question of this in the upcoming question. I will definitely do it. So this is already we have done, so I'm skipping it. This is x square minus 2a. So this a is there. How to do this? This is fx equals x square minus 2x. So if you take x as a, fa will be equal to a square minus 2a. So you have to compute this. A square is this whole square, and just multiply these two matrices, and a square will come, and minus twice of this a. So I'm just writing a square, directly writing a square. I hope you'll be able to do it. A square, I'm directly writing the value. A square is 496 20 29 8 8 16 9 minus twice of a. Multiply this matrix with 2 and write it here. Minus 2. I multiply every element by 2. So 0, 2, 4. Then 4 2s are 8, 10, 0, and 0, 4, and 6. I multiplied everything with 2. Now see, just subtract it. 4 minus 0 is 4, 9 minus 2 is 7, 6 minus 4 is 2, 20 minus 8 is 12, 29 minus 10 is 19, 8 minus 0 is 8, 8 minus 0 is 8, 16 minus 4 is 12, and 9 minus 6 is 3. This is your final answer. fx equals x cube plus 4x square minus x. Fa is this. So again, same thing. In place of x, just replace it by a. So let me show it here. It will take a lot of time to do it. So this is fx equals x cube plus 4x square minus x. Replace x with a. So it will be a cube minus 4a square minus a. So now you have to put a square, a cube, and a. You can reduce your effort by taking a common, but ultimately you have to multiply a again. A square minus 4a plus I. So this computation becomes easy, but if you want to do it, you can do it. Otherwise, you have to follow the proper procedure. So let me show it to you here only. See, a is there, a square. This value will come. Then you multiply this again with the same matrix. A cube will come. A square and a cube we have got. So a cube you write directly, but multiply a square by 4. That is value a square by 4. And then subtract it with the a. This value will come. Show that the root of the polynomial this. Okay. So this will do. Thank you so much. Take care of yourself next time.